Hi, my name is Joaquin van Schoren, and this is a tutorial about querying the experiment database for machine learning. Now, the experiment database is a large database which collects experiments with data mining algorithms. So it runs them on different data sets under different parameter settings, and if I have a question, I can just answer that question by using the results of those millions of experiments. For instance, if I have a new data set, I can see which learning algorithms can run on that data set. I can see how they perform on similar data sets, for instance, data sets with large number of attributes. If I have a new learning algorithm, I can see how my algorithm compares to all the ones that have been proposed before. And if I'm interested in a specific learning algorithm, I can ask specific questions. For instance, I can see the effect of a certain parameter setting, or I can see how the algorithm performs on different types of data. So any question you have, you can answer by just typing a query. The first way to do this is to type a query in SQL. For instance, if I want to see all the names of all the learning algorithms, I can just type select name from learner, and this will give me a list of all the learning algorithms. And of course, you have to know the names of the attributes and the tables. So if you don't know that, you can also use a graphical interface which shows the same tables, and it shows also how they are connected. So the experiment always has a learner algorithm, which is run on a dataset, which is then evaluated using a certain evaluation method, for instance, tenfold cross-validation, and will have outputs, basically predictions and evaluations. There's also admin data, but we'll skip over that. I can also expand nodes, so if I, for instance, see the output, I can see the different nodes that are beyond that. So if I left-click output, it will expand. I can see I have evaluations. I get per class evaluations, for instance, for precision and recall, which are calculated per class. I can also ask for the predictions of the algorithm, and I can ask for the confusion matrix for classification problems. If I'm not interested in a certain table, I can right-click it and it will disappear. So I can just right-click output and all the children will disappear. You also have the green and red things here. So the green boxes allow you to select attributes. For instance, if I click learner, I can see I have the attributes name, function, description, class, and so on. So if I ask for the name of the learner, this will generate a query. If I then submit it, I get the same list. Right? So if I want to know the names, I just click name and that's it. If I want to add a constraint, for instance, I want to have a certain class of algorithm, I can click here and V will give me all the values. For instance, trees will give me only the algorithms based on decision trees. If I submit this, then I'll get only those learning algorithms based on decision trees. I can also change or write my own constraints by just typing in the field here. If you want to start a new query, you can just right-click experiment and left-click it, and you will start over. For datasets, I can ask for a name, description, the data group, for instance, UCI is a data group, the task it belongs to, the URL where you can download it, so on. If I click on data, I can also get the properties of the data, for instance, the number of attributes, or I can ask how the data is being preprocessed. If I click here, for instance, I can see that we start from this data set. I can add constraints. I can then preprocess it using a certain preprocessor, for instance, feature selection, which will give me a new data set which I will then experiment with. Let's remove this now. So one question I could have is to get all the names of the data sets and then to ask for a property. So I can add a constraint of which property I want. So I ask for name, and then I get all the different properties. So that's class count, class noise, class entropy, a whole list of statistical properties, signal noise, the year where it's published, but also things like the number of attributes or the number of examples. So let's take the number of attributes. And this will give me a new query, which if submitted will give me the names of all the data sets, yes, with all the number of attributes. If I click visualizations here, I can draw scatter plots. So here I get all the dataset names and number of attributes. So I can see that some datasets have really large number of attributes, but most of them have a very small number. Okay, it's time to ask your actual query. Say I'm interested in seeing how different learner algorithms perform on a specific dataset. Then I need learner data output. I will remove admin and evaluation setup. I ask for the name of the learner. I want a specific dataset, so I add a constraint on the dataset. So name is, and then I get a list of all the datasets that are stored. Let's take better. Okay. I will also add a constraint saying that I want the original, the non-preprocessed version. This is just a flag. It's true. Then I want it's like the output that I want. I want one number evaluation, so I'm going to remove the other ones. You see below here is evaluation metric. So if I expand this, I get the evaluation metric, and I can choose basically any metric that I want. So name is, and I get a list of all the metrics. So there's area under the ROC curve, bias variance, root mean square error, precision recall. I will just take predictive accuracy. This is a simple query. I submit it, get about 4,000 results. And if I then visualize it, I see all the learner names here and the predictive accuracy. So you see that some algorithms have quite a bit of variance. For instance, for vector machine as results between here and here. That's because there's still different parameter settings and different kernels. Also for ensembles, you will have different base learners. For instance, boosting here, there's bagging here, there's boosting again here, eta boosting here. Some algorithms like C4.5 have many parameters, so it also gets quite a bit of variance. You can easily zoom in on the data and get more detail. For instance, say I want to look at sport vector machine results and see what is causing this variance. Then I go back to the query graph. I add a constraint that I only want sport vector machine results. So name is sport vector machine. Submit. So this just removes all the other results. I only get sport vector machine results. Okay, then I want to see the kernel, for instance, that's being used. Now you see that the learner has a double edge. It means if I click it, I will get more detail. So if I do this, I get 3 nodes. First is learner, which is this general learner name, general algorithm. There's implementation, which is implementation details, so the name of the implementation, the version of the implementation, the library where you will find it, the URL where you can download it, and some other information. There's also properties of learner algorithms, for instance, whether it can handle missing values, can it handle numerical features, also things like the bias variance balance of the algorithm. Finally there's the learner application, which defines how the algorithm is being run. Basically you have 2 things. You have parameter settings and we have components. So components can be anything that's part of a learner algorithm, for instance a kernel and kernel algorithms. A function, for instance a nearest neighbor, this can be a distance function, or it can be not a learner. For instance in an ensemble algorithm like bagging, you can have a base learner, which is part of the algorithm. I was interested in the kernel, so I will just select the name of the kernel. Okay, I submit this, and I will get the results for the differentiated in between the different kernels. This is the OBF kernel, this is the polynomial kernel. I can give different colors. If I go to color settings, I can choose kernel name, and I get different colors. I can also change the colors if I want to. So we go back now, you can see that, well, if you go back to learner, these are all sport vector machine results. You see the blue ones are polynomial and the red ones were OBF. You can see there's still a bit of variance here in the RBF, which is caused by the parameters of the RBF kernel. So I can go back to the query graph and I can go even deeper into the kernel. So now I can have implementation application again. So here are the parameter settings. and then I will just ask for a specific parameter setting. So I just go here, parameter. Now I can ask for the name, it will give me the implementation name, or I can ask for the alias, which is a generally better known name for the parameter, because sometimes different implementation use different names for the parameters. So I can see that our RBF kernel has the gamma parameter, which basically defines a kernel width. It's also some other parameters. So if I take the gamma here, I will submit it again, and now I will see these were my results, and if I then choose the gamma value, I can see that these results here are spread out depending on the value of the gamma parameter, right? So now I get a very clean overview of the performance of the spot vector machine using the RBF kernel with different parameter settings for the gamma. So I can see that performance goes up if I use a larger gamma value and then slowly goes down again. So this is only for one dataset. Say I'm interested in the other datasets as well. So one thing I could do is just move this around, get more space. Say I could just remove the ladder constraint here, which will give me all datasets, but then I will get 100. So I will just select a few datasets. So if you click it, you can also ask for additional values. So I go down list again. I'm going to choose some other datasets. Let's take about 5 or so. One more. Let's take this one. Okay. So if I submit this again, I will get the same results, but instead of one dataset, I will get different datasets. So now I see the different lines. Let's add a color to the name. Oh, I have to ask for the name of the dataset, of course. Submit. So now I get different colors for the different datasets. And the colors you will find here in the list. You can see that for ladder and other datasets, performance is high for almost all values of gamma, but mostly around this area. And for other datasets, performance goes down really fast to default accuracy if I use a larger gamma value. So one question you could ask is, what's the difference between these datasets and these datasets? Well, to do that, I can go back to my query graph and I can ask for properties of the datasets. Okay, I'll move this. And then I can again ask for the properties of the dataset. So let's say I ask for the number of attributes. There you go. I submit it again. I'll visualize it, and then I will need 3 dimensions. So first I select the gamma, second I select the number of attributes, and then the performance. Okay, and then I see that for a small number of attributes, you get these curves, where the gamma value increases then slowly decays. And for a larger number of attributes, you will see the performance goes down really fast if I use a large gamma value. This is because for larger values, the kernel width becomes smaller, which will overfit my data. Okay, finally, if I am happy with my query, I can also save it. So if I click save, I can give it a name. I can also load it again. There you go. You have to rewrite it again. There's also a list of examples. For instance, this will compare different base learners. So I select the bagging algorithm, I ask for the name of the base learner, and the rest is more or less the same. So this is at least some introduction. Have fun and writing your own queries. Goodbye.